Hello, everyone. My name is Jennifer Marsman, and this crazy contraption you see me wearing on my head is a headset that can read EEG, or your brain waves. And I took this headset, and I put it on my husband, and I asked him a series of questions. And first, I had him tell me the truth, and then I made him lie to me. And what that gave me is a labeled data set of what his brainwaves look like when he's telling the truth and what they look like when he's lying. And so if you know anything about machine learning, you know you can take that data, feed it into a machine learning algorithm, and then build a classifier to perform lie detection. So that's what we're going to talk about today. I do work for Microsoft. If you do have questions that don't get answered today during the session, feel free to reach out to me on Twitter, on my blog, and then Tim Huckabee and myself are also going to be doing an Ask Me Anything immediately following this session on the 4th floor, so I'm happy to take questions there as well. All right. So let's talk about this. Taking a step back, what is EEG? And of course, for the official definition, we can turn to the source of all knowledge, which is, of course, Wikipedia, right? So you can read the official definition there. Essentially, what it is the electrochemical signals that are going through your brain that can be measured in a very non-invasive way. For those of you who were in the room early and saw me messing around getting this thing on my head, you saw that the headset has actually little felt pads. And so I took saline solution, the same thing I use on my contact lenses, and put that on the felt pads. And then that helps it read the signal. So it can kind of read those signals that are going on in your brain. And I don't think I need to say this to anyone in the room, but just in case, I can actually do mind reading with this, all right? You put this on someone's head. You don't know what they're thinking or anything like that. But what I can do is I can create mappings between patterns of EEG and actions, either in the physical world, so for instance, like making a drone fly with the power of your thoughts by thinking up, 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 or in the digital world. And I'm going to attempt to show you that in a minute by trying to move a cube with the power of my mind. And then secondly, I can see patterns in this data, or more accurately, I can train a machine to see patterns in this data and to learn based on historical data what those patterns actually mean. So using in supervised machine learning, you can use historical data from the past to make future predictions. So we're going to see how to do that as well in the field of lie detection. All right, so let me just start with a quick demo. So this headset is actually made, this isn't a Microsoft thing. I do work for Microsoft, but this is not a Microsoft thing. This is actually made by a company called Emotiv, which has offices in San Francisco as well as Taiwan. It's a female-founded company, woohoo! And so, yeah. So it's a great, but it's a really neat headset that I have been just lusting after forever. The founder of the company, Tan Lee, did a demo with it as a TED Talk way back in 2010. And ever since then, I wanted this headset so badly. So I want to show you a little kind of snippet of what some of the people are doing with today and some of the things that got me super excited about it. So I'm going to start by showing, this is a piece of software that actually is made by Emotiv that came with Emotiv's, with their actual software. So this isn't software I wrote. This is software that comes with the headset. And it shows you a couple things. So you can kind of see that everything is reading green right now, which is good. That means it's got strong signal from all of the 14 nodes resting against my scalp, so that's great. If I switch over to here, you can see, if I look this way, is it looking that way? One way, the other way? Yeah, OK, cool. When I'm looking, I can't actually see what's happening in front of me, so hopefully that's working. Blinking, blink, 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 some blinks. And then raise your eyebrows, smile, big smiles. So I didn't actually train it for this one, but you can see it's picking up some of those things. Now, why this is important and where this is going to come into play later is that facial movements also feed into EEG data. That's what you should be taking away from this. So just moving your face is enough for it to pick up with EEG. So some of this is actually affecting the data. So just bear that in mind. And then this is the demo that really got me excited about this headset when it was first shown as a TED Talk all those years ago. And so what I'm going to attempt to do right now is move that cube with the power of my mind, OK? So everybody's brain has a unique signature, much like fingerprints, where we all have slightly different fingerprints. Your brain has a unique signature as well. And so, everyone, I'll show you actually in just a second, I can show you like the wave patterns and such. So like my waves might spike at like 24 and my husband's might spike at like 3. So you need to take into account things like that. So what I'm going to do is start by just training what my brain looks like at a neutral state. All right, so this is just going to be me. I'm going to train it for neutral. So what's going to happen is it's going to take 8 seconds. And I'm just going to try to close my eyes and go to my happy place in front of a crowd of 650 people staring at me. I'm going to try to relax and just like try to think kind of nothing at all. Just kind of go to a neutral, relaxed state. Okay? So we're going to do that for 8 seconds. There's going to be an awkward little silence, and we're all going to be OK with it. All right? And then when I am going to close my eyes, so when it says done, will somebody just yell out loud, it's done, you can open your eyes. OK? We good with that? OK, thank you. All right, so we're going to train now. 8 seconds, happy place. Here we go. Training now. Thank you. You guys were awesome at that. OK, so I'm going to go ahead and accept that training. I think I was sufficiently relaxed. And now what I'm going to do is there's a series of actions that they've already programmed it to do, right? And so I'm going to do pull. I'm going to imagine pulling the cube towards myself, OK? And so what I'm going to do now is I'm going to think, pull with my mind, OK? So this is just pattern matching, right? We're just doing really basic. This isn't even machine learning here. I'm just thinking, pull, and what it's going to do is take the pattern that my brain waves are using, and I don't necessarily even have to think pull. I could be thinking hamster dance, but whatever I think, as long as I'm thinking that thing consistently whenever I want it to pull, it should work, right? Does that make sense? All right, cool. So now we're going to map that pull in my brain activity to that motion. So now I'm going to train it again by thinking pull for 8 seconds. It'll be another 8 seconds here. All right, so now we're going to go ahead and pull. Oh, what was that? That's not good. There we go. Ooh, OK. Yikes. All right, so it lost signal right in the middle of training, so that's not good. But let's see if we can get this up. All right, so let's try one more time. Hopefully that didn't affect anything too bad. And here we go. 1, 2, 3. OK. I'm going to say no. I'm actually going to train it one more time because I was not totally focused there because the blip threw me for a second. So let me do it one more time, a little more focused. All right, 1, 2, 3. Here we're going to go. Train. Here we go. OK, so now when I hit yes, the cube is going to be live. So now what we're going to do is see if I can kind of repeat that pattern of motion. I'm going to try to think pull the same way I was thinking before and see if we can actually make this cube move. OK? All right, let's do it. All right, now pull. Uh-oh. Yikes. Come on. Yeah! I just moved the cube with my mind, right? Let's do it again. Yeah. You have not lived until you've moved a cube with your mind. I'm not going to lie. I feel like Jean Grey every time I do that. It is so cool. All right, that's the whole reason I bought the headset, really, was to do that. OK. So you can see how I got pretty excited about the potential applications here. So let me just show you a quick 2-minute snippet of what people are doing with this device today and some of these potential potential applications. So this is a really just a short part of Tenley's TED Talk from back in 2010. Then if you would like to, you can go back and watch the whole thing. It's only like 10, 12 minutes long. It's pretty short. So go watch the whole thing later. But let me just show you what people are doing today. And I have to hit the play button. There we go.
So I'd like to show you a few examples because there are many possible applications for this new interface. In games and virtual worlds, for example, your facial expressions can naturally and intuitively be used to control an avatar or virtual character. Obviously, you can experience the fantasy of magic and control the world with your mind. And also, colors, lighting, sound, and effects can dynamically respond to your emotional state to heighten the experience that you're having in real time. And moving on to some applications developed by developers and researchers around the world. With robots and simple machines, for example, in this case, flying a toy helicopter simply by thinking lift with your mind. The technology can also be applied to real-world applications. In this example, a smart home. From the user interface of the control system to opening curtains or closing curtains.
I love this dude, because notice how he always uses his hands and does the, like, these are not the droids you're looking for thing. Like, watch him. He's got to do his hand. These are not the droids you're looking for. He's my favorite. He's awesome.
Also to the lighting.
Yeah.
Turning them on.
Now, this is actually my favorite application of the technology, though, right here.
And finally, to real life-changing applications, such as being able to control an electric wheelchair. In this example, facial expressions are mapped to the movement command.
Now blink right to go right. Now blink left, turn back left. Now smile to go straight.
All right, we'll cut it off there. We'll cut it off there. But so you can see there's a lot of really cool things that people are doing with this already. There's a lot of academics and researchers and a lot of people exploring. And it could be anything from game development. So imagine like having a real-time feedback loop where you could tie into people's emotions, right? So let's say you can actually sense, one of the things I didn't show you is there's kind of a sense of like excitement level that's mapped. So imagine that you're playing a game and you can actually sense that the user's getting a little bored. So like make another zombie jump out, right? So you could actually base it real time on the actual user's feelings and expressions and how they're interacting with the game and be able to add additional stuff based on that. And then of course, the thing that really gets me, there's kind of the smart home applications and other applications as well. But my favorite is the one at the end, when you consider someone like the case of a paraplegic or someone paralyzed from the neck down, being able to use facial expressions and the power of their thoughts to move an automated wheelchair. Like those kind of things are really exciting to me when we have the power to use technology to make the world a better place like that. So all these life-changing examples, all these cool things that we can do to benefit humanity, and what does Jennifer choose to do with it? Lie detection on her husband. Yeah, way to help humanity, Jen. So let me tell you where I kind of got this idea. You guys probably watch all the same criminal drama shows that I do. So you've probably heard the fact that some people question how effective polygraphs are. And so the typical polygraph where you're measuring things like galvanic skin response, like how sweaty your palms get, and your blinking rate and your heart rate and things like that. And the critics of this method say that those things actually measure your emotional response. So if you're really nervous, sometimes you get the same effects as if you were really guilty versus lying, or telling the truth versus lying. And so I started thinking, so again, let me say really clearly, I do not claim to be a neuroscientist. I have very little, there's actually very little known about the brain. It's amazing how much we still don't know about the brain. But I did get my master's degree in artificial intelligence and machine learning. And I did take like one brain science class while I was there. And one of the things I remember is that when you're telling the truth, that tends to activate the recall centers in your brain. And when you're lying, that tends to activate the creative centers in your brain. So I started thinking, if I have this headset that's reading from these 14 different points on my head, could I do that? Like, would that maybe be possible? So it was one of those things where I just started this as a fun side project. Let's see if this would actually work, and tried it out. And so in good little former graduate student thing, I listed out my goals and my tools and blah, blah, blah. OK, so here's the fun part. My actual experiment procedure. So my first victim here was my actual husband, and I sat him down in a chair, and I did make him close his eyes, and the reason for that was actually two reasons. Number one, I was actually sitting next to him because I had the headset has to stay pretty close to here so that it picks up over, it uses a proprietary technology, kind of like Bluetooth, to talk back and forth, and so I didn't want him out of range. So he was sitting pretty close to me, and I didn't want him reading the questions over my shoulder because I was actually putting a mark in the data when I started asking the question and like when he finished answering. So that way, with all this brain data, I could slice out just the part where he was thinking about the answer, right? And so if he was reading it over my shoulder, then I wouldn't be getting an accurate slice of when he was actually processing the information. Does that make sense? All right, so that was one reason. And then the second reason was because you guys saw earlier how when you actually, let me run the other thing as well. I'll run test bench and show you this for a second too. When you do have a whole bunch of, here, I'll come back to this for a second. When you do have facial movement, that gets picked up in the data. Because remember how we were able to pick up like the blinks and the smiling and the raising eyebrows and stuff in that data? So EEG, these things are actually affected by facial movements too, right? So I didn't want him to be like scratching his face or blinking or anything like that. So I just said, just to get the data as clean as possible, like in the test runs, I said, can you just close your eyes and just listen and answer like that? So that was the second reason. And then I ran this tool called Emotiv Test Bench, and I'm launching that right now for you, and we can see that in a second. But I asked him a series of questions, and those are some of the questions right there at the beginning. And I asked him truth and then lie and differentiated the data. And I did do a nice confusion matrix where some of the correct answers to these are yes, and some of the correct answers to these are no, because I wanted there to be a nice confusion matrix of like true, false, yes, no. I wanted things in every single quadrant, right? And so like, we don't have a dog? Then no, we don't have a dog. Yes, he does have a PhD. No, he doesn't have red hair. Yes, he's married. No, he does not have 5 children. Well, at least he does not have 5 children with me. He may have 5 children, but if so, then we have another problem. So all of those things I asked, and let me show it to you real quick just so you can see like the actual process. So I was using this tool. This is Test Bench, which also came with Emotiv. And you can see, oh no, I went orange on one of them. That's okay. So what this actually does is here's all 14 of the different signals right here. And so you can see if I kind of go calm for a second, pretty flatlining there, and then, yeah, that makes it crazy. So you can see that. So you can see kind of different brain activity and how it actually shows up like in the thing. So it's pretty cool. So that's what this does. So this is the actual EEG readings, and you can turn off certain things. So the different sensors, if you want to focus just on certain sensors, like I can turn off some of these readings and just look at some of them and focus in on certain ones too that I find to be more useful. And then when I was actually collecting this data, I used this little marker tool where I was sending manual markers. So if I open, where did I put this? Documents, Emotiv. So here's one of them. Actually, let me do the data too one. I think that one might be a little better. So I have a couple markers here, and so for example, this question asked thing. So I could, when I was asking Eric the questions, I could say, ask the question, or I think I hit question asked, said the question, got his answer, and then sent a question answered. And you can actually see the little 1 and the 2 in the data here, so that allows me to extract out. I just went through and wrote a little Python script afterwards to be able to extract out just those signals and then move them over. Does that make sense? Good, you guys see that's pretty straightforward? Okay, cool. The sampling rate is 128 readings per second. If you do the math on that, that works out to approximately every 8 milliseconds it's taking a reading, so pretty good there. All right, so that's all I can think of to say about that. So let's go back here then for a second. And then, and here's the documentation of the actual process. That first run, I wanted to document it like for my blog and stuff later. And you can tell my husband is really happy about helping me with this research. No, Jennifer, I don't have an Ashley Madison account. Can I please go watch TV now? No, honey. I'll decide when we're done. Ha ha ha. Okay, and then here's the sensor quality. So for those of you who, again, were in the room a little early, you might have seen when I was putting it on my head, before it went all green and beautiful like that, there was actually a lot of yellow and red and black and Jennifer shifting around chunks of hair so that I can have yet more pictures of me on Twitter with crazy hair. So it's actually really funny. If you look at when Emotiv actually presents this stuff, every single time without fail, they use a bald guy. Because they're so easy. Like my husband is also follically challenged. And like when I put the headset on him, it's just like you put it on and bam, it works and it's fabulous. With me, it's like a 20-minute long process of, okay, getting it on and then shifting chunks of hair around to make sure it's getting a good reading everywhere, and it's a complete pain. But anyway, so you can see though, once it's reading, there's basically an enumeration of different levels of signal quality. So you can get, it's really good to use for data cleaning later to make sure you're getting the highest quality data signals. And so green is represented by 4, so that means that's the strongest signal quality. And then there's progressive levels of signal degradation. So yellow next, then orange and red, and then black means it's not reading any signal at all. All right? And then all of that is collected in the data too. Actually, I didn't show you the data. Do you guys want to see the data? Let me jump over to the data. So when I record that in test bench, like I was showing you here, as that data is being recorded, then they actually store it in a proprietary format, but then they give you a nice little convert to CSV thing with it. And so you run the convert to CSV, and then once it's a CSV, it looks a little something like this. Can you guys read that okay? Or do you want me to make it a little bigger? I'll do a tiny bit bigger. Okay, so here is what the data actually looks like. So first of all, there's a counter. The counter actually just counts up to 128 and resets, and because that's the 128 readings per second, so that kind of gives you the sampling right there. And I did not use that data at all. I just threw that out. I threw this out as well. Here are the actual relevant values. So these are the 14 different places, and I'll show you how those map to areas on the scalp in just a second. But we have something AF3, F7, F3, kind of all these fun names, O1 and O2. Et cetera, et cetera. And so those are our 14 different things right here. And then we actually have, there's a gyroscope in there as well, so measuring kind of the angle of your head. And I did not actually use this in my first runs, but that's kind of on my to-do list that it might be fun to play with someday. Because if you think about it, if any of you guys watch like the World Series of Poker, and you know how sometimes like more inexperienced poker players have little tells, well maybe they're tilt their head a certain way when they're lying or something like that. So there might actually be something to that data. So that's like on my list to play with someday, but I haven't done anything with it so far. But that's the gyroscope stuff. Here's the marker column. So the marker column, remember when I was sending markers, I sent the 1 when the question was started, and then a 2 when I finished, he finished answering, so I could extract out that stuff. This will read all zeros except for when I sent the 1 and the 2, and then I can just parse this file and then pull out everything between a 1 and a 2 and use that as a single question answer session. Here's the sync. This doesn't matter. Here's the timestamp. The way they do timestamp is a little bit crazy because they have it as 2 separate things. So here's the seconds value, and then here's the milliseconds value in 2 different columns. So I actually do something at the end to make those a single time value as opposed to 2, just to make the math easier. But here's the value in seconds, the value in milliseconds. And then this is the CQ represents contact quality. So that's those levels from 4 to 0, from green to black that I was showing you before. So you can see kind of when you first get started and it first goes on your head, it might read 0 for a second, and then this one was reading green after that. So that's good. And so what I did when I was collecting data is I would throw out all this 0 stuff at the beginning to get a good accurate data. All right, so here's contact quality, and I have that for each one of the 14 different sensors. So our contact quality for each one of these, and you can see where they map to the places on the brain based on the diagram I'm going to show you in a second. And then here's where their data ends, right here. And then after that, I added 3 columns myself. The first column is my label, right? Because in machine learning, we need a nice labeled data set if you're going to do supervised machine learning. So for this particular session, this person was telling the truth. So I put is truth is 1. So now I have that this is truth data marked in there. And so then when I make predictions, when I want to predict if something is truth or not, it will give me 0 if it's lying and 1 if it's the truth. And then here's the time value, and this is just using those 2 values that you had before, taking the seconds times 1,000 plus the milliseconds to get the time all in one value. like so. So I did that right here. And then after I did the initial experiment on my husband and such, I wanted to see if I could do it general purpose. So I started collecting data from lots of different people. And just for privacy reasons, I wanted to not associate their names with it. So I put, this is user 18 in my data right here. And so here's user 18's data. All right. So that's just a quick look at the data that I was getting. So now, if we jump back here, you can see we already saw this, the signal quality, and that was represented in the Excel spreadsheet by that CQ underscore each one of those names. And then here's the actual mapping of where those different things. You saw those columns in the Excel spreadsheet. Here's where they actually map to the positions on the brain. And this is a heads up thing, so you're looking from the top downward, where that little bump on the top is the nose, and those are the ears. T7 and T8 are right here. So you're kind of seeing this view right here. Eek, right? Like that. AF3 and AF4 right here. Here's the T7, T8. The ones that like hurt your ears in the back are O1 and O2 right here. So all of those are the various sensors that we have here and where they map to places on the brain. Okay. So now, one of the things that I did do was usually when you have an idea that you think is super cool, someone has already thought of it, right? So I did go out on the internet and did some research and thought, hey, has anyone thought about doing lie detection in conjunction with EEG before, and what has been their results and such? And I was doing some research on this, and I did read about something called the P300 ERP. And so some government agencies and researchers are looking at this, and what this actually does is the P300 ERP response actually measures that flash of recognition. So let's say you're walking through NDC Sydney here, and you're walking through the crowd, and you see someone, and you get that, oh, I know that face from somewhere. You know that feeling you get? That's the P300 ERP response. So it's that, oh, I know that from somewhere. And maybe you don't remember the context of, they could have gone to kindergarten with me. Maybe I worked with them. Maybe I saw them at a user group before, whatever. But that little flash of recognition is called the P300 ERP. And if you look at it if you look at it plotted, this is what it actually looks like. It's this little dip, or this kind of big relative dip that you see right here. And it's the reason they call it P300 is because it's activated roughly 300 milliseconds after the visual stimulus that you get. And so you can see right here the dip, 300 to 500 is probably more accurate, but it's a little dip that you see right afterwards. And so government agencies have actually used this response in EEG in conjunction with lie detection. So the idea is, instead of like a polygraph where you're asking people yes or no questions and measuring those responses, you have a headset like this, or probably a better quality one, or maybe a hospital grade one, I don't know. But you use some kind of EEG detector, and you can then say things like, I shouldn't say that this is actually a really, really good headset in terms of like the value. There was actually a study done. I was reading studies about the various EEG readers, and this one is one of the highest in terms of like the amount you pay versus how high quality the signal is. It's very, very good. So I am actually a huge fan of this headset. So what they actually found is, so if we're trying to use this in conjunction with detecting guilt, right, and lie detection, what they did is they sat a person down and had a headset on their head, and then showed them images, right? So they put pictures in front of them. Some of them were like just neutral images, whatever. But then say you put a picture of the crime scene, or the murder weapon, or something like that. And if you put things like that in front of them and they get that flash of recognition, then that can show that, okay, maybe they know more than they think they do, or they have seen this before, or there's some kind of recognition happening. And so they actually, some people are experimenting with using this to help with lie detection. And the little chart that you see right here is actually probably the silliest way of saying this, but essentially what that means is if the information of what the suspect recognizes correlates to something that someone with no intimate knowledge of the crime should know, then maybe they're guilty, right? And if they know something that they shouldn't know, then maybe they're guilty. And if they know something that someone who didn't know anything about the crime doesn't know, then it's probably okay. So very, very straightforward thing right here. If the This is the information the suspect is expected to know, information that should not be known to the suspect, and then information of the crime that only a perpetrator would know. And so if they know stuff that is correlated to information that only the perpetrator would know, then maybe they're guilty, right? Like, kind of like, duh, right? It's a lot of pretty charts to say it. Something pretty simple, but kind of cool. All right, so what I took away from this, this was really, really interesting stuff. It's a little different than the way I was approaching it. But one thing that I took away from this that was really, really useful is I was actually wondering, I had no idea in what time frame these responses were happening, like in terms of number of milliseconds after the stimulus. And so knowing that something like that recognition flash actually happened, 200 to 500 milliseconds after the stimuli, I was like, OK, my sampling rate of 128 readings per second, which is roughly every 8 milliseconds, is probably good then, if I'm getting the every 8 milliseconds. So that was a big takeaway for me that, OK, because that's one of my concerns was, is the sampling rate high enough? Am I getting information fast enough to be able to know if this is working well? And from this, I was like, OK, I think I'm probably good with every 8 milliseconds then. OK, so now let's transition for a second to Azure Machine Learning. So I used Azure Machine Learning to implement this. I work at Microsoft, and so I like to play with all of our new technologies for machine learning. And there's a lot of cool stuff we have, machine learning. There's some new stuff that's going to come out in the Ignite timeframe, which I'm really excited about. There's the CNTK, which is our deep learning open source framework. So we have all kinds of cool tools. Cognitive services, which are some pre-built models that you just call with a REST API. So we have all kinds of cool stuff. And so for this, I was just playing around and wanted to kind of rapidly iterate and stuff. So I chose Azure Machine Learning. And Azure ML is pretty cool. There's 25 pre-built algorithms that are already included in there that you can call and utilize. And there's a whole bunch of modules for importing the data and cleaning the data. And then you can train models and test models. And then the deployment story is beautiful. It's literally like a button press. And it takes your model, stands it up as a REST endpoint, generates a token so that only people with that security code can call the web service. And it's so easy. Like, the deployment is just awesome. So that's one of the things I love the most about it, because usually deployment is the worst. So that's really cool. So that's kind of some of the power of Azure Machine Learning. So I use that. And here is one template that you can use if you were looking at Azure Machine Learning and trying to figure out, it's a web-based tool, so you don't need to download a lot of stuff. So you go there, and you kind of have to drag and drop little modules and string them together to create a data flow. And so in this case, you could take a data set like this, and then do some kind of data cleaning, and I used various modules for that. And then machine learning, we split our data. And the reason for that is, if I have this nice labeled data set of, here's all this, great EEG data, and then here's whether he's telling the truth or lying, if I fed it all of that data, and then I went back and I wanted to see if it worked, and I, took some of that data and said, OK, for this EEG pattern, is he telling the truth or lying? It's already going to know the answer, right? Or something pretty close to the answer, because I trained on that data, right? So it's not going to do as, I can't really trust the answers that it's performing that well. So typically in machine learning, what we do is when we have a nice labeled data set like that, you hold back a certain amount of the data. So you can, assuming the law, there's lots of different ways to do this. There's cross-validation and some other techniques as well. But one technique you can use, assuming you have a sufficiently large data set, is to use just a simple 30-70 split. So I take 70% of my data, train it with that data, and then hold back 30%. And then once I've built that trained model, you send in just the features, so just the EEG data of the 30% you've held back, see what the model generates, and then I can compare that to those known right answers that I've held back. Does that make sense? OK, so that's why we do that in machine learning. So I took 70% of the data, trained a model with that, and then this outputs a trained model, essentially. And then I take that 30% of the data I held back for my test data, I apply it, and what that does is the score uses only the features, puts it into the model, gets back the results, and then compares it to the known right answers that we have in the test data. And then that gives it a score of accuracy numbers, precision, recall, things like that. And then you can evaluate that side by side with another model. So I do that exact same thing over here, but maybe over here I use a different algorithm, and then I compare the two and see how well they do. Or once I've settled on an algorithm, I start tweaking the initial parameters, because that can affect accuracy and things like that. So this is kind of the art part of data science, where you iterate and iterate based on your data and see how you can get the best results there. All right, so does that all kind of make sense? All right, the one big thing that's probably still missing here is, okay, Jen, if you just said that there's these 25 different algorithms, if I don't have a machine learning background, how do I know which algorithm to feed into the model? So enter the Azure Machine Learning cheat sheet, cheat sheet, cheat sheet, cheat sheet. So this is an amazing thing with a large, friendly do not panic button right in the middle. And so what this does is actually give you a lot of different ways to use, talk about data. So you can do things like, so regression and classification. So those are both forms of supervised machine learning. With supervised machine learning, we're, again, taking that historical data from the past, a labeled data set of historical data, and then using that to make future predictions. And the difference between regression and classification is that regression predicts a number, right? So like the cost of a home, how much your energy bill is going to be, things like that you would use regression for. And then classification is when you're predicting between distinct categories. So who's going to win the World Cup? This team or Brazil? Who is going to, are my sales numbers going to be over or under? It doesn't have to be binary either. It could be, what color does this series of pixels most closely map to? Red, orange, yellow, green, blue, et cetera. All right? So that's classification, is when you're trying to predict between discrete buckets, discrete categories. And then regression is when you're predicting a number, right? And then anomaly detection is really interesting. Anomaly detection is when you're trying to do this with a highly unbalanced data set, okay? So imagine the problem of credit card fraud detection, all right? When you have your whole database of all these, all this credit card data, you may have a whole bunch of, valid transactions, and then out of your whole data set, probably the number of fraudulent transactions is going to be a really small subset, and then the number of known fraudulent transactions is probably going to be even smaller still, right? So you have a very small number of known fraudulent transactions, and then you have all of these valid transactions. And so when it's a very unbalanced data set like that, it's hard to build a conventional classifier using some of the other methodologies. And so anomaly detection is something that can specifically account for that. So basically, you can train it with what normal looks like, and then when you get something that's kind of outside the bounds of normal, you can utilize that. So credit card fraud detection uses anomaly detection. I've used it for oil and gas pipelines to detect, problems with pipeline flow. Network intrusion detection, it's really good. We use it on our networks at Microsoft. Fun fact, people try to hack the Xbox Live network like all the freaking time. Like everybody wants more gamer points, right? So like that network is like constantly being things. So we have like network intrusion detection, algorithms running on that all the time. So all kinds of cool stuff with anomaly detection. And then clustering is actually unsupervised machine learning. So we've been talking about supervised machine learning using a labeled data set to make future predictions. That's supervised. Unsupervised machine learning, you don't need a label with your data set. You can just have a whole bunch of data, and then clustering algorithms just group like things together. So that's really good for things like building a recommendation engine. You might want to group like movies together or like restaurants together so that people who like one might like others and that sort of thing. OK? All right, so quick test. If I have a bunch of EEG data and I'm trying to predict if my husband is telling the truth or lying, should I use classification, clustering, anomaly detection, or regression? Classification! 10 points to Gryffindor! Yes, that is a classification problem. So we would go here, predict categories. Am I predicting 3 or more or 2 categories? 2, right. I was just predicting between truth or lie. I did not ask any questions like, does this dress make me look fat? Where the answer may be somewhere in the middle. OK, so that is exactly right. So then you can go and use these algorithms are the best ones to kind of get started with. And then if you look at the cheat sheet, it actually gives you a whole bunch of really great information about where each algorithm shines. For example, SVMs, that stands for support vector machines, those are really good when you have lots and lots of features, like over 100 features feeding into your algorithm. The things that predict your label are your features. So if you have a whole bunch of things that might affect it, SVMs work really well. There's linear models right here, as well as nonlinear things like decision tree ensembles here. And you can see like the boosted decision trees are really, really accurate, but they also take up a large memory footprint. So it kind of tells you some of these kind of pros and cons of each of them. So you can kind of look at those and decide, OK, which one might work best, and try a couple of those. I usually start with one linear and one decision tree to start and see how it's performing better, and then iterate from there. based on that. Because if a linear model works, great, because they're super fast. But they don't always work, because real life is messy. All right, so if you would like to download that cheat sheet and print it out and hang it in your office like all the cool kids do, you are totally welcome to. You can download it at aka.ms/Azure Machine Learning cheat sheet. And then I also have a blog post that I did on getting started with Azure Machine Learning if you'd like to play around with it more yourself, and that's at aka.ms/hackml. That's got a whole bunch of interesting things. So one of the things I put is if you want to just get better at machine learning and practice it, you need two things. Like, number one, you need cool data sets to play with, and then you need cool problems to solve. And so I give you, here's a whole bunch of places that have really cool data sets. So like, I have sources of where you can find cool data to play with. I have a tutorial, like an end-to-end walkthrough is linked from there. A link to where you can provide feedback, which is actually, if you guys don't know about that, you know the Microsoft user voice thing where you can go and submit feedback? That is really good to snoop on if you guys don't do that right now. Like if you want to see what's coming, because they actually mark some of them as this is in development, or this is, we're still talking about it. This is in consideration, in development, whatever. So you can kind of see what features are coming sometimes if you snoop around in there. So just, you didn't hear it from me. So really, really cool stuff. But there's a whole bunch of great resources linked from there. I did write it for a student audience. So the actual title of the blog post is How to Win a Hackathon with Azure Machine Learning. Yeah! But just ignore the spin in the first paragraph, and the rest of it is just like getting started with Azure Machine Learning. All right, and then if you'd like to see an end-to-end demo for like how do I get data into Azure ML, how do I do data cleaning with it, because that part is really, really important, how you get the data in a format that a machine learning algorithm can use it effectively. And then how to train a model, test a model, deploy a model, call the model, all of that stuff. I have a whole end-to-end demo predicting whether or not someone would survive the Titanic based on demographic information about them, like their age, their gender, how much they paid for their ticket, stuff like that. So you can go and check that out. There's a video of that online there. OK, so now I ran this on my husband. I collected the data. I've explained the experiment procedure. I put it into Azure Machine Learning. So let's go look at it. Here is my model that I built. And I am going to right-click on the Evaluate at the very end and hit Visualize. And there is a chart here. I'll show you how to read it. So this is a chart that plots the true positive rate versus the false positive rate. So false positives are when you say something is true and it is not in fact true. And true positives are when you say something is true and it is true. All right? So false positives are bad and true positives are good. So perfection would be if we had false positive rate of 0. So to plot that on the chart, 0 would be like that, all the way up. And then true positive rate, we would want that to be 1, which is 100%, and go all the way up here, choop, choop. All right, so essentially the tighter it hugs this curve, the better your machine learning algorithm is performing, okay? So you want it to be as close, hug this as tight as possible. And then this is usually really hard to see on projectors, but there is like a thin gray line that goes up the middle right here. So this is essentially 50-50 random chance, a monkey flipping a coin, all right? So you want your algorithm to be performing better than that. If your algorithm is not performing better than that, start over. There was a problem there. Go back to the drawing board. All right? So you can see this one is doing kind of meh. This was the linear algorithm. But this one, this was the decision jungle, is actually doing pretty well. So if we go down and look at the data here, you can see the true positives and the true negatives are high, which is good. We want those to be high. And then the false negatives and false positives are low, which is good. And then we have an accuracy of around 93% and high precision and recall and stuff as well. So I started to think, oh my gosh, there might be something to this. Maybe this is preliminary stuff, but it looked kind of like there may be something to this. And so literally, you guys, I think it was like a week or two right after I had done this initial work with my husband, my team had an offsite. All right, so I work on a distributed team. My manager sits in Minneapolis. I sit in Detroit. We're like spread out all over the US. And so, once or twice a year, the whole dysfunctional family gets together and we have an offsite and we talk about our stuff and all that kind of thing. And so, and this was the year when we had a commitment. One of my jobs was to do a whole bunch of Channel 9 videos. You guys know Channel 9, Microsoft's YouTube, channel9.msdan.com, good stuff, okay, go watch them. All right, so that year, we had a goal where we had to deliver, we had to create X number of Channel 9 videos that got, Y number of views each, so they had to be not only Channel 9 videos, but popular Channel 9 videos, those kind of things. So that was one of our views. So our marketing department had actually hired a camera crew and brought them to our offsite, just in case you guys feel like making some videos right now. Just go ahead, But that gave me an idea, right? This had kind of worked on my husband. So I grabbed my manager and I was like, hey, remember that headset that you let me buy? I've been doing some initial machine learning work with it, and would you mind if I just put it on you and asked you a few questions? And he was like, yeah, sure, whatever. And he didn't really know what I was doing yet. So I got my manager, and then I grabbed the camera crew, and I was like, let's have some fun. All right, so first I had to build a classifier, and I wanted to build it specifically for my manager's brainwaves, okay? Because I haven't done the work to generalize across all people yet. So first I asked him a bunch of questions and made him tell me the truth.
Are you a female?
No.
Are you a male?
Yes.
Have you ever worked for Microsoft?
Yes.
Okay, so you guys get the idea, right? And then I made him lie to me.
Do you have a PhD?
Yes.
No, he does not.
Do you currently have a pet?
Yes.
Nope.
Do you have blue eyes?
Yes.
Okay, so you guys get it right. Now, what would you do if you had access to your manager's brainwaves?
Do you believe Microsoft is the best company in the world to work for?
Yes.
Am I going to get a promotion this year?
Yes.
Okay. So you guys all heard that totally awkward little giggle, right? So what did it mean? Did it mean he had some good news and he couldn't share it, or did it mean I totally suck? I had to know. So I did what any girl would do, and I ran back to my hotel room that night and built a classifier with his brainwaves. So what I did was I did the same process that I had done with my husband. I took the truth data, uploaded it to Azure Machine Learning, took the lie data, trained a model that was specific to my manager, deployed it so it stood up as a REST endpoint, and then I wrote a really ugly Windows 10 app, because as anyone who has ever seen a Jennifer Marsman demo knows, I am not that good at UI design. I'm really good at algorithms, yeah, but design has never been my strong point. So I made this really, really ugly Windows 10 app, and all it does basically is it calls the web service, and so I trained with just the truth and lie data, and then I was going to ask it. This program will basically ask it the two questions that I asked at the end, that data. All right, and we'll call those. And then I also tried to do something cool, and I made a little thing that gave you the confidence levels as well, so it'll show how true or how much of a lie we think it is. All right, so here we go. Do you believe Microsoft is the best company in the world to work for? My manager said yes. My algorithm says, oh! He has an iPhone. And he's really into design. I'm just saying, we might have a closet Mac fanboy on our hands. All right, and then the real important question, am I getting a promotion this year? My manager said yes, and my algorithm said, yeah! And I am delighted to announce that I did get the promotion. So you can see there's a lot of things you can do. This is just I've had so much fun working on this project, and I have all these other ideas for how you can use machine learning in conjunction with EEG. I can't even, there's so many. Here's a couple of things that I'm looking at doing next. Oh, okay. So after kind of the initial data runs that I did with my manager and my husband and such, I did kind of some second data runs. I don't expect you to read all this, so let me just call out a few major points. So the first couple of runs I did, I just did one marker per question, and then I took a time interval around it. And so then after that, on the second run, I started doing like a marker before I ask the question, all of that, and then a marker after they answer, so I get all the data more accurately. I started taking neutral brain state recordings. So one of the things I need to do still is like normalize it across all people so that I could just plop it on anyone's head where I don't have training data for them and see if I can do it. So to be able to do that, I started, you even saw how when I was doing the thing at the beginning where I was pulling the cube towards me, it needed a neutral brain state to be able to normalize my brain waves versus kind of like the collective wholes. So I started taking neutral brain state recordings for people as well, so that way I could use that for data normalization. I started asking more questions, because the more data, the better. And it's a pain to get it on someone's head, so once it's on, I want a lot of good data per person. Oh, this is kind of interesting. So I started switching order to reduce fatigue effect. So the idea behind that is fatigue effect is at the very beginning, like if I take your data, at the beginning, it's kind of fun, right? Because this crazy lady puts this headset on your head, and then she's asking you all these questions, and you're like, this is kind of fun, and you can see your brain waves or whatever, and it's kind of cool. But it gets boring really fast. Okay? And so what was happening is if I ask all the questions where I ask people to tell the truth first and then lie, like that excitement emotion might kind of get all correlated with the truth data and then kind of the boredom at the end associated with the lie. So what I did was for some people I asked them to tell the truth first and then lie. And then for other people, I asked them to lie first and then tell the truth. So that way that, kind of the emotional response will get distributed throughout the data. Does that make sense? OK, so that's the fatigue effect. All right, and then I started asking additional data about the test subject as well. So have any of you guys seen that show Brain Games? Do they have it in Australia? I'm not sure. OK, yes, I'm seeing some nods. OK, well, there's this show called Brain Games, and they do all kinds of tests with the brain. Like they had some driving challenges where they took like older, more experienced drivers who had more driving experience, and then had them like do an obstacle course where they like throw stuff in front of you while you're driving and you have to swerve and stuff. And then they had younger drivers who were less experienced driving, but their brains were maybe a little bit sharper because they were younger. And they compared the two of them against each other to see who would do a better job and that sort of thing. And so I started collecting, and actually the younger people won, which was kind of interesting. Beat the older drivers, were able to avoid the obstacles better. So for the small sample size they did have, it wasn't a huge study. But anyway, so I started collecting a couple extra things like age, for one, just in case there is degradation in the brain over time. I collected age, I collected gender, I collected whether you're right or left-handed, because have you guys heard the thing that maybe that correlates to the dominant side of your brain? I don't actually know if that's true or not, but more data is good and I don't have to use it, so I started collecting that as well. So all kinds of extra data, too, that I can use. And then finally, mixing truth and lie in a single session. So I asked them to tell the truth and then lie, like back to back, to kind of try to tease out some of those confounding variables to make sure it's not stuff that's specific to a session that gets in there rather than the actual truth or lie. All right, so here's some of the questions I added. There's a couple of them in there. They all were meant to be yes or no questions. Although there's some other stuff in there too that we won't get into it right now, but there's other stuff that some situations when you wouldn't necessarily use those. And then extra data, I already talked about this, user IDs, the gender, whether they're right or left-handed. Here's the fun part. OK, so here's different ways I started doing feature extraction on this data, because I have all this interesting data. So this is time series data, right? So it's these waves like that. And so there's different ways you can do this. So one thing is unrolling the waveform. And what that means is essentially I have over time, so for each one of these 14 sensors, I have data over some time interval, which is specific of how long that question answer lasted. And so you can basically take like all 14 of them and like unroll them in the same order and then use that as kind of your whole feature vector. So that's one way to do it. Another way is something called wavelets. So what that is dividing a time signal into frequency bands. And there was actually a really good EEG thing on Kaggle. If any of you guys are familiar with Kaggle, it's a data science competition site. And they did a competition about being able to differentiate if someone was trying to grasp with their hand versus lift. And so you can think of the application for a paraplegic, or for someone who had their arm removed or an amputee. If you were able to give them a prosthetic and then in their brainwaves map what it looks like when they're trying to grasp versus lift, you could actually kind of build some of that into the prosthetic potentially. And so there's just some interesting applications there. And then the person who actually won this actually did it using some of the low frequency time domain stuff. So there might be something to that too. So I was playing with that. There's a wonderful Pi EEG library by Forrest Shengbao. I have never met him, but I am eternally grateful because he open sourced it. And so I used that and pulled in some of the feature extraction that he was using. Another thing is state machines. OK, so this is actually kind of interesting, because when you think about all the stuff that is actually happening in the brain when I ask these questions, like from the user perspective, first they have to listen. So they actually have to decode those signals and figure out what it is that I'm asking. So they have to do the auditory work to figure that out. Then they have to kind of process the question, see what I'm asking. Then they have to decide whether they're going to tell the truth or lie. Then they have to come up with an answer. And then they have to do the work to, the auditory work to actually say it out loud, right? To vocalize the response. Okay, so there's kind of like a mini little state machine happening in there. And if I can zoom in on that and then zoom down even further into just like the truth-lie part of that, that will help be more effective. So I was hidden Markov models kind of work well with state machine type things. So that's another thing I was kind of playing with. Comparing to the neutral brain state, I already kind of talked about that. So to be able to normalize across all people, you want to do that comparison of kind of everyone's brain waves against the average to be able to make better predictions. ERP, so I talked a little bit about that. I'm sorry, I never defined it when we were talking about the P300 ERP, but that stands for event-related potential. And so it's actually a different way of processing EEG where you're taking some essentially averages over time, so it kind of helps weed out some of the noises, or some of the noise. So using ERP instead of the raw EEG is another thing that I've kind of played with. And then ensembles are a technique in machine learning where essentially you use multiple classifiers together, and then some of them can kind of help account for the error of previous ones. So you can ensemble a bunch of things together. And if you look at who is winning these Kaggle challenges, almost everyone is using an ensemble to do that. So it's basically kind of matching up a lot of things together. Or I'm sorry, using a lot of classifiers in conjunction to come up with the best results. And then finally, deep learning, I think, is honestly the key to solving this, right? Because if you think about what I'm really trying to do, it's really, really similar to the problem of speech recognition, right? You guys have all seen audio files. You know that when you talk, it makes these audio waveforms, which are very similar to the brain waveforms that I just showed you, right? And everybody has slightly different voices, different timbres and pitches and all those other things that I don't really understand because I never really paid attention in music class. But you know what I'm saying? Those things are all in each of us speaks a little bit differently, but it can still recognize, hopefully, the words that we're saying when we're saying the same words. And that's what speech has done. And so really, it's a very similar thing where it's, again, time series waveform data that I'm processing. And and everybody has a brain signal that's a little bit different, much like our voices are all different. So it's really, really, really kind of similar problems. And speech recognition has been solved with deep learning. Like, it's a solved problem at this point. And so I think deep learning could actually solve this too. The only reason I haven't done it yet is because I don't have enough data. With deep learning, you actually need to use lots and lots of data to do it effectively. And I've been kind of collecting headset data from people in my spare time, with my high-stress job at Microsoft and my 3 children and all that. So it hasn't gone as quickly as I would like. But when I do, deep learning is a great thing. And there are great tools like the CNTK, as well as things from other companies that can process those. OK, so that's some of the techniques. So the next steps, I'm collecting data from lots of people now to be able to do a general purpose one as well. I'm experimenting with different features to improve the accuracy. Like you saw on the previous slide, those are some of the things I'm experimenting with. And then implementing a real-time feedback loop. There's something. The thing that's holding me back there, otherwise this would have been done a long time ago, the only thing that's holding me back there is that I need that thing to convert this from the proprietary format into CSV automatically, and they actually have that embedded inside of their tool, and it's not like a command line thing that I can call. And so I've been going back and forth with Emotiv support, trying to get them to just give it to me as a console app. And then once I have that, that should be like not hard to code. So, and then what I could do there are some really awesome demos where I can stick it on someone live and ask questions. So I want to do it to Satya. Microsoft CEO. Dream big, right? Reach for the stars. All right, and I do want to say thank you to all the people. So when I had an early version of this, and I demoed it to the Azure Machine Learning team, and they all started drooling. And we're like, can we help you? This is so cool. So I do want to say thank you to all the people who have helped me and made suggestions on the experiment procedure and Python scripts and all kinds of other stuff. A whole team started helping me with this, and the ending result is so much better now based on everyone who was able to contribute some stuff. All right, so in summary, this headset is awesome. It's so cool. I've sold all these other ideas, and I do feel like Jean Grey every time I move something with my mind, which is fun. Azure Machine Learning is an amazing tool. It made it really, really fast and easy to get up and running with this technology and to iterate quickly and try different things, and I really, really love it. And husbands and managers, beware. Mind control is next. Thank you guys so much.